Hey guys, welcome back to another Mathin' with Coach Lynn. Today we're going to talk about understanding rates and unit rates. So if you turn to page 65 in your book, on lesson 1.8, it tells us, I can understand how a rate is related to a ratio and use ratio and rate reasoning to find a unit rate. So the first thing we need to do is define the terms that we have throughout this lesson, which are ratio, rate, and unit rate. A ratio is a comparison between two quantities in which for every A units of one quantity, there are B units of another quantity. Units in a ratio can be alike or different. Some examples of a ratio are 6 laps to 4 laps, or 4 laps in 6 minutes. A rate is a special kind of ratio in which the units are different. Okay, so we said the units are different. So in this example, we see 6 minutes for 4 laps in 6 minutes. So instead of in the ratio where we were going laps to laps, now it's specifically minutes to laps or laps to minutes. A unit rate is a rate in which the first quantity is given for every 1 unit of the second quantity. And the units will be different. So an example is 1.5 minutes per lap and 2/3 laps per minute. Now let's look at example 1 on page 67. Example 1 tells us a scientist studying hummingbirds recorded that a hummingbird flapped its wings 1,590 times in 30 seconds during normal flight. Assuming a constant rate, how many times did the hummingbird flap its wings per second? So there's 2 methods to solving this problem. The first method is we can set up a ratio table. All right, and since we are comparing the wings per second, we'll have our wings on top and our seconds on bottom. We know that it can do 1,590 flaps in 30 seconds, but we want to know how many flaps it can do in 1 second. Well, we know 30 divided by 30 will give us 1 because any number divided by itself equals 1. So we're going to divide the top number by 30 and we get 53 flaps per second. The second method we can use is using equivalent rates. We set them up similar to a fraction. Since we did wings per second, right, flaps per second, we put our flaps on top, 1,590, the seconds on the bottom, 30. And similar to our ratio table, we just need to work back to 1 second because we want to know per second, which is 1 second. So we're going to divide by 30, and again we see 53 flaps per second. Now at the bottom of the page, they say, the scientists also recorded that a hummingbird took 6,250 breaths over a period of 25 minutes. Assuming at a constant rate, how many breaths per minute did the hummingbird take? Now at this time, I want to point out that they gave us 6,250 breaths over a period of 25 minutes. And then in the question they said, how many breaths per minute did the hummingbird take? When I see a problem set up where it says something per something, so in this case we're going to say A per B, this is the same as telling me A divided by B. So my quantity A divided by quantity B. In this case it says breaths per minute, so I'm going to do breaths divided by minutes. So I'm going to do 6,250 breaths over my 25 minutes. And that's going to give me a division problem. Looks similar to a fraction. We know fractions are division problems. So 6,250 divided by 25 will give me 250. So in 1 minute, per minute, in 1 minute, the hummingbird breathes 250 times. On example 2 on page 68, we're going to find the unit price. So the price per a unit. And it tells us for Carolina's birthday, Her mother took her and 4 friends to a water park. Carolina's mother can pay either $130 for a 5-pack of student tickets or $28 for each individual student ticket. Which ticket payment option has the lesser unit price? So the unit price given for buying tickets individually is $28 per ticket. So we need to find the price for the 5-pack. How much is each ticket individually in that? So in order to do this, we know that's $130 for 5 tickets. So we can use a ratio table to scale back. 5 divided by 5 is 1, so we're going to do the same thing to the top. 130 divided by 5 is 26. So it's $26 per ticket. So we see the 5-pack is cheaper by $2 per ticket. If we're buying 5 tickets, then we know we are saving $10 in all. Also, if we look at our thing, like I said earlier, if it tells us price per ticket, we know it's the price divided by the ticket. That's what we did here. Since our price is on the top and our ticket is on the bottom, and we ultimately divide it by 5, so 130 divided by 5 gave us the $26 per ticket. All right, our check problem at the bottom of the page tells us a sporting goods store sells a package of 20 baseballs for $25.95 or single baseballs for $1.75 each. They want to know which option has the lesser unit price. So when we're talking about unit price, we're always talking about the price per whatever the item is, price per the quantity. So it might be how many of the item you're getting, the ounces, pounds. There's many things you can go to, but the price is always going to come first. So since we know it is price per ounce, pound, quantity, the price is going to be divided by, because we said earlier, per tells us to divide. So in this case, we're going to do $25.95 divided by 20. When I do $25.95 divided by 20, I end up with 1.2975. Since we're talking money, we can't have that many decimal places. Money only goes to the hundredths place. So we need to round to the nearest hundredths. Since our next number after 9 is a 7, we know it's going to round up. So the 20-pack of baseballs come out to $1.30 per baseball. Whereas if we buy the baseballs individually, they're $1.75. So it's cheaper for us to buy the 20-pack. Now let's work a couple of problems together on page 71. Number 1 states a hippopotamus can run 6 kilometers in 15 minutes. At this rate, how far can the hippopotamus run in 1 minute? Similar to our per, if we see in the middle of two quantities, it's going to tell us divide. So in this case, we see 6 kilometers in 15 minutes. This is telling us 6 in 15, which is similar to a fraction, 6 in 15. So 6 divided by 15. When I work this out, I see that the hippopotamus can run 0.4 kilometers per minute. I also can simplify the 6 over 15 to a simpler fraction. We can divide them both by 3. 6 divided by 3 is 2, and 15 divided by 3 is 5. So it's the same as 2/5 of a kilometer per minute. 0.4 and 2/5 are the same. One is just written as a decimal, and one is written as a fraction. Now let's look at number 3. A cat's heart beats approximately 45 times in 15 seconds. At this rate, how many times does a cat's heart beat per second? Okay, so we have some key terms in there that really trigger us to know what we need to do here. We see the term beat per second. Since we see beat per second, we know it's going to be beat divided by seconds. And they tell us in our word problem that the cat's heart beats approximately 45 times in 15 seconds. Another, as we said earlier, up here, 6 in 15. So we're going to do 45 in 15. So 45 divided by 15. If we do 45 divided by 15, we get 3. So we know the cat's heart beats 3 beats per second. All right, guys, hopefully this will help you understand rates and unit rates. And as you go forward, you can apply this to our lessons and ace your assignments. Have a good day.